Welcome back to Math with ACE, focusing on statistics with ACE. We are continuing working with discrete random variables and calculating expected value and standard deviation and answering questions. For this example, suppose we're playing a game with a biased coin. And what that means for a biased coin is that when you flip the coin, it's not equally likely to be heads and tails. Right now, you play each game by tossing the coin once, and the probability of heads is actually 2/3. So you're more likely to land on the heads than you are the tails. If you toss a head, you pay $6. If you toss a tail, you win $10. If you play this game many, many times, will you come out ahead? They're asking us, what is the expected value? So let's define the random variable of x and then determine what we would expect the value to be. So will I come out ahead? If I'm trying to determine will I come out ahead, it's how much money do I make? So I want x to be the profit. So here, x is the profit. We already have the x filled in. Well, we know in the table, we then need to have the probability. So this would be the probability of x. What's this third column over here? Typically, when we're trying to calculate expected value, we need to multiply the value times its probability. So this next column is going to be x times the probability of x. But let's fill in the first value, 10 times a third. When you multiply fractions, whole numbers always go over 1. And you have times 1/3, and you multiply straight across. You don't need to find a common denominator. I do 10 times 1 is 10, and 1 times 3 is 3. That's 10/3, which is not a great decimal, so I am going to leave it as a fraction. Well, if I lose, I was told if I toss a head, I pay $6. And if I toss a tail, I win $10. So this is tail, and this is head. So I need to pay $6, and I represent pay with a negative sign. Okay? The probability then, remember the probabilities have to sum to 1 whole. So 1/3 plus 2/3 is going to give me 1 whole. And then let's verify that that's -12/3. -6/1 times 2/3. A negative times a positive is a negative. 6 times 2 is 12, and 1 times 3 is 3. Now I've completed the table. What is the expected value? I need to just sum those. What is 10/3 plus -12/3? Thankfully, they have a common denominator. I can just keep that denominator. And I'm dealing with 10 plus a -12. That's 10 minus 12. You have more negatives than you do positives. So when your signs are opposite, what you do is you subtract. So 12 minus 10 is 2, and you keep the sign of the bigger number, which is negative. -2/3 is about 67 cents. So I'm going to lose just under $1 when I play this game. That's what I would expect. Do I come out ahead? No, I'm going to lose money, which is how most games are designed. That's why they say the house always wins. What's our next example? So we're going to toss a fair 6-sided die twice. So what that means is fair means that each side is likely to happen. So if you have the values 1, 2, 3, 4, 5, and 6, they're each likely to occur. I want x to be the number of faces that show an even number, and I want to construct a table, calculate the mean and the standard deviation. So first of all, we need to look at our sample space to determine this. So if we roll a die, we have the numbers 1 through 6 on one die and 1 through 6 on another die. So I'm going to complete a chart to fill in those possibilities. Okay, here is my sample space. There's 36 possible outcomes. 6 on the first die, 6 on the second. You multiply the two, you get 36. Green is the first die, blue is the second. And so what we're looking for is the faces show an even number. Faces are even. So for all of the even faces of green, That's 1, 2. There's 3 different possibilities for green. Let's look at the blue. 2, 4, and 6 are even as well. So when I have just pink, that's 1. When I have just yellow, that's 1. But when I have yellow and pink, that's when 2 faces are even. So the options are neither of the 2 die are even, one of the 2 die are even, or both of the 2 die are even. So in my probability distribution, I have 0 faces, 1 face, or 2 faces. All of the ones that don't have any highlighting are my 0. So let's count those. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 9 out of 36, which if you divide is 1/4 or 0.25. 1 would be the ones that are not double counted, one or not double highlighted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There is 18 out of 36, which is half. So then the remaining, the ones that are double, 1, 2, 3, 4, 5, 6, 7, 8, 9. So half the time we're going to have at least one face, or we're going to have one face that is even. 1/4 of the time we'll have none, and 1/4 of the time we'll have both. So let's multiply those two together. 0 times 1/4 is 0. 1 times half is half, and 2 times 1/4 is also half. So what would we expect? We would expect 0 plus 0.5 plus 0.5. That's going to give me 1 whole. We are going to expect that we will get 1 even face. What is the standard deviation? In order to calculate the standard deviation, I need to take each x value minus the expected value, square that, and multiply it by the probability. So the x value here of 0 minus 1, which I expect to happen, squared, times the probability of 0.25. The x value of 1 minus 1 squared times the probability of 0.5. And the x value of 2 minus 1 squared times the probability of 0.25. So these are the values, and then the expected value was 1. So I'm going to use my calculator. This is going to give me 0.25, because 0 minus 1 is -1. -1 squared is 1. 1 times 1/4 is 1/4. The second one is going to be 0, because 1 minus 1 is 0, and 0 times anything is 0. And then the third one, 2 minus 1 is 1. 1 squared is 1. 1 times 1/4 is 1/4. Now, if I sum that, I'm going to get the variance of 0.25 plus 0 plus 0.25. That's going to give me a variance of 0.5. So then the standard deviation is found by square rooting 0.5, which is about 0.707. So we have a standard deviation of 0.707, and we have an expected value of 1 for this problem. Let's look at our last problem. There was an earthquake, so on May 11th of 2013 at 9:30 p.m., the probability that moderate seismic activity, so one moderate earthquake, would occur in the next 48 hours in Iran was 21.42%. Suppose you make a bet that a moderate earthquake would occur in Iran during this period. If you bet, you win $50, if you win the bet. If you lose the bet, you pay $20. And again, X is the profit. The probability of winning is 21.42%. The probability of not winning is the complement, which is 100% minus 21.42%, which is 78.58%. If you bet many times, will you come out ahead? This is asking what is the expected value. Explain your answer in complete sentences using numbers. What is the standard deviation? Let's construct a table to answer these values. All right, so we have a win and we have a loss. Those are our two options. Winning is when you win $50. So that's the X value. The probability of winning is 21.42%, which I'm actually going to use the decimal equivalent of that when I'm moving forward because it's easier to work with that. Losing means you pay $20, which is minus 20, and that had a probability of 78.58%. So I'm going to write this as 0.2142 and 0.7858. Okay. Now, to calculate the expected value, we do the X value times the probability. So 50 times 0.2142 is 10.71. Negative 20 times 0.7858 is negative 15.716. If I add those two together, I get negative 5.006. So I expect to lose $5 on this bet. So what that means is if I make this bet many, many times, my long-term outcome will be an average loss of negative $5.01. So I'll write that in a sentence. And I don't want to say, I put a negative sign, but I don't want to say a negative loss because that actually is a positive. So loss represents the negative sign. So now I need the standard deviation. Well, you know, we need the next column to be the X value minus the expected value, square that, and then multiply that by the probability. So the X value was $50 minus that expected loss of 5.006. So it's actually minus a negative squared times the probability of 0.2142. Then I have negative 20 minus that negative 5.006 squared times 0.7858. Using my calculator, I'm going to do 50 minus a negative 5.006, square that, and multiply a 0.2142. And I get a first value of 648.096. And the second one, negative 20 minus a negative 5.006 squared times 0.7858, I get 176.664. The variance is then found by adding the two together. $648.096 plus 176.664 is 824.76. The standard deviation is then found by taking the square root of 824.76, which is 28.719. So what that means is that on average, we're off about $28. So this isn't great. We would lose money. Again, each one of these examples where you're playing a game, you're losing. So that's why gambling is not always great. If it was great, everybody would do it, right? Thanks for watching.